plywood factory can consume more than 3,000 tons of wood every day. But its secret is not cutting logs into thick boards. It is peeling them into veneer layers only about 3 millimeters thick, then pressing them back together to create a material more stable and more resistant to warping than natural wood. From there, the entire production line is designed to extract almost the full value of each tree. Logs weighing hundreds of pounds are softened with heat, peeled into continuous sheets, dried to a controlled moisture level, coated with industrial adhesive, cross-laminated, and pressed under intense heat and pressure. This process allows the plywood industry to use up to 95% of the raw material, turning rough timber into panels used in millions of homes, offices, truck floors, furniture, and construction projects around the world. Behind this industry, worth more than 50 billion USD, is the art of taking apart the natural structure of wood and rebuilding it into something stronger, more stable, and more useful. Join Factron Process as we explore the full journey of plywood production. Every sheet of plywood looks simple, but it is a highly engineered material behind modern construction. Used in homes, offices, warehouses, and commercial buildings, plywood now reaches more than 100 million cubic meters in annual production and around $56 billion in global value. Though layered wood dates back over 5,500 years to ancient Egypt, modern plywood only boomed after veneer peeling and pressing technology advanced. After World War II, production jumped from 3.11 million to over 10 million cubic meters in just 11 years. So how are raw logs turned into this strong, durable, engineered wood? The journey of a plywood sheet begins in carefully managed industrial plantations. Tree species such as pine, eucalyptus, sengun, and meranti are grown in cycles of 6 to 25 years to produce straight logs with fewer knots, making them suitable for veneer peeling. Once the trees reach harvesting age, logging machines move into the forest, grip the trunk with hydraulic arms, cut through the base with a saw, remove the branches, and divide the trunk into sections in just 30 to 60 seconds. The logs are then loaded onto specialized trucks and transported to the factory. A large logging truck can carry 40 to 50 tons of raw material, while major factories may receive more than 3,000 tons of wood per day. In the receiving area, massive log grapples lift each trunk onto a conveyor, where laser scanners measure its length, diameter, and straightness. This data allows the computer system to sort the raw material. Qualified logs move into the plywood production line, while the rest is routed to other processing lines to maximize the value of each tree. From the receiving area, the logs continue into the debarking machine. A roller system holds each log firmly and rotates it continuously, while hard steel teeth scrape away the outer bark. A log more than 20 inches in diameter can have its entire surface cleaned in less than 1 minute. The purpose of this stage is not only to remove the bark. Soil, sand, and small stones stuck to the surface can damage the veneer peeling blades in the next stage. Interestingly, the removed bark is not wasted. Bark can account for about 10 to 15% of a log's volume, so at many plywood factories, these layers of bark are ground into biomass fuel and burned in boilers. That heat is later used for drying and wood treatment stages inside the factory. The freshly debarked logs continue rolling toward the cross-cutting area. Many logs are more than 40 feet long and weigh several tons, and they are continuously carried by conveyors through a laser scanning system. Laser beams run along the trunk, recording the diameter, straightness, and shape of each log, before sending the data to the control system. Immediately afterward, industrial saw blades that can exceed 6 feet in diameter begin operating. When the signal is sent, the saw blade drops at high speed and cuts through the log in just a few seconds. Each large log is quickly divided into blocks about 8 to 9 feet long, matching the size of the veneer peeling machine used in the next stage. The freshly cut wood blocks are not peeled immediately. Instead, cranes lift them one by one and lower them into hot water tanks or move them into massive steam chambers. The temperature inside is usually maintained between 122 and 176 degrees Celsius for 12 to 48 hours. During this process, heat gradually penetrates deep into the wood and softens lignin, the natural polymer that acts as a binding agent between wood fibers. As the lignin becomes softer, the log turns more flexible and much easier to peel. From the outside, this may look like a simple wood soaking step. In reality, it is the stage that determines how much raw material can be recovered in the next stage. If the wood remains too hard or the heat has not penetrated deeply enough, the veneer may develop cracks and tears, significantly reducing production efficiency. The wood blocks that have just left the heat treatment area are delivered to the veneer lathe. A hydraulic system locks a block about 8 to 9 feet long between two chucks, and then the motor begins rotating the entire block around its axis. Once the speed stabilizes, a blade more than 8 feet long slowly moves toward the wood surface and begins peeling away the first layer of material. Within just a few seconds, a continuous ribbon of veneer starts flowing out of the machine. As the log becomes smaller, the blade keeps advancing toward the center to peel each new layer. Electronic sensors monitor the remaining diameter of the block in real time and automatically adjust the blade position to maintain a stable veneer thickness of about 1.5 to 3.2 millimeters. When the remaining diameter of the log drops to about 3 to 4 inches, the lathe stops operating and ejects the leftover wood core. But the journey of the log is not over. These wood cores are sent to other processing lines to be cut into pallets, stakes, landscape timbers, or many other construction products. At large factories, hundreds of these cores are reused every day instead of becoming waste. That means even the final remaining part of the log continues to deliver value. And this is exactly why the plywood industry can use up to about 95% of its incoming raw material, an efficiency level that very few wood processing industries in the world can achieve. After leaving the lathe, the long, continuous veneer ribbon is not sent straight to drying. First, it passes through a high-speed scanning system where cameras and sensors scan the surface to detect knots, cracks, holes, or weak edges. With a veneer ribbon that can stretch more than 1,300 feet if laid out straight from a large log, cutting in the wrong place can waste a large amount of valuable material. As soon as the system identifies defective sections, the clipper knife drops and cuts the veneer ribbon into individual sheets. Clean, flat sections with fewer defects are kept for the outer faces of plywood. Sections with minor defects are used for the core layers, while material that is too poor is cut into smaller strips or ground into wood chips. This is why a modern factory is not simply cutting veneer. It is constantly making decisions to use every part of this thin wood layer, only about 1.5 to 3.2 millimeters thick. In a large production line, tens of thousands of veneer sheets can be cut, stacked, and sorted in a single shift. The freshly cut veneer sheets still contain a large amount of water. Depending on the wood species, the initial moisture content can range from 30 to 60%, far too high for glue to bond properly. For that reason, each veneer sheet is spread onto a conveyor and fed into an industrial drying system, a drying tunnel that can stretch up to 100 to 200 feet long. Inside the machine, powerful fans blow hot air across both sides of the veneer. Each thin sheet of wood moves through multiple heat zones, gradually losing moisture while still maintaining the flatness and flexibility needed for production. The final goal is to reduce the moisture content to about 6 to 8%, the ideal level for glue application and plywood pressing. A large drying system can process more than 500,000 square feet of veneer per day, equivalent to the area of nearly 9 American football fields. This stage may look simple, but if the veneer is too wet or too dry, the finished plywood can become weak, warped, or delaminated after years of use. After leaving the dryer, the veneer does not go straight to the glue application area. The wood sheets continue through a grading system, where scanners and workers inspect each sheet to evaluate surface quality. Clean veneer sheets with fewer knots and uniform color are selected for the outer faces of plywood because this is the part users see most clearly. Sheets with small cracks, wormholes, or minor defects are sent to the repair area. Machines or workers can cut away the damaged sections, patch them with wood plugs, or fill them with suitable material to preserve the usable portion. This stage helps the factory reduce the amount of defective veneer that would otherwise be discarded. Qualified veneer sheets continue into the glue spreader. As they pass through a roller system, a thin layer of industrial adhesive is applied evenly across the surface to bond the wood layers together. For interior plywood, factories often use urea formaldehyde glue because of its low cost and good bonding performance. Meanwhile, plywood designed for damp environments or outdoor use commonly uses phenol formaldehyde glue, which offers better water resistance and weather durability. Right after glue application, the veneer moves to the layup line. This is the step that creates the secret strength of plywood. The wood layers are not placed in the same direction. Instead, the grain of each layer is rotated 90 degrees compared with the next layer. A common sheet of plywood may contain 3, 5, 7, or 11 veneer layers, depending on thickness and intended use. What is especially notable is that a sheet of plywood, less than 3/4 of an inch thick, can still contain multiple thin wood layers crossed inside it. This structure makes plywood more stable than solid wood because each layer helps restrain the shrinking and warping tendency of the layer beside it. After the veneer layers are assembled, the stack is still loose and easy to shift. For that reason, it is sent into a pre-press machine. The cold press plates lower and apply enough pressure to hold the layers in place, spread the glue more evenly, and push some of the trapped air out of the panel. This step helps the veneer stack keep its shape before it enters the most important stage, hot pressing. At the hot press, each veneer stack is placed between large steel plates. The press closes and applies pressure that can reach about 150 to 300 psi, while the temperature usually ranges from 230 to 320 degrees Fahrenheit. Under heat and pressure, the glue begins to cure, locking each veneer layer into one unified sheet of material. A multi-opening press can process dozens of plywood sheets in a single cycle, transforming wood layers only a few millimeters thick into thick, strong panels. After leaving the hot press, the plywood sheets continue into the final machining area. Here, high-speed industrial saws cut away the excess edges formed during pressing while bringing each sheet to its standard size. In just a few seconds, a rough panel is shaped into a 4 by 8 foot sheet, the most common size in the North American construction industry, and one that appears in millions of homes every year. After being trimmed to size, the plywood sheets continue into the sanding line. Wide industrial sanding belts rotate continuously, passing over both faces to remove slight raised areas, press marks, and small irregularities left from production. As the sheet moves through several sanding units in sequence, electronic sensors continuously check surface thickness and flatness. If the system detects an area that does not meet the required level, it automatically adjusts pressure to make the entire panel as evenly finished as possible. In the final stage, each plywood sheet passes through the quality inspection system. Industrial cameras, laser sensors, and quality control workers evaluate thickness, flatness, surface quality, and the bonding strength between veneer layers. Once the sheets meet the required standards, they are graded and stacked into bundles. One bundle can contain from 40 to more than 60 plywood sheets, depending on product thickness. Forklifts then move these bundles, each weighing thousands of pounds, to storage areas or load them onto trucks, trains, and shipping containers. From here, the plywood sheets begin their final journey to construction sites, furniture factories, and building projects around the world.